Today I am going to discuss about Argand diagram. Also I shall discuss about modulus and argument of a complex number. Here Argand diagram, it is a graphical interpretation of complex numbers. So I am taking here complex number as z equal to a plus bj, and it is plotted as a point with coordinates AB, and the real part of Z, I mean A, it is plotted on the horizontal axis, which I can call it as real axis, and the imaginary part of Z, I mean this B, it is plotted on the vertical axis as an imaginary axis. So such a diagram, this total diagram, we can call it as Argand diagram. Sometimes it is also called as complex plane. So here I am taking 4 complex number to plot those. So what I am doing, I am bringing a graphs. So I am taking all the complex numbers as a coordinates in terms of here 3 by 3, here minus 3, 4, and here 2 minus 4, here minus 3 minus 4. So I did the procedure same as this one. Now here one interesting thing, for these 2 arrow I draw, the reason is to show that this complex number and this complex number, we can call this pair as a complex conjugate, because these two lie symmetrically on opposite sides of this real axis. So let's move in the next slide to see how to get modulus of a complex number. So here same diagram, only additional things I have done here. See this distance of this point from the origin. So I put a line here. Distance, this one. And I can represent this distance as absolute z equal to r. Why I put absolute? The reason is the modulus is never negative. This r, it is the modulus. So how to find this r? So I am putting this color to indicate that this is a right angle triangle. So I have to apply Pythagoras theorem to get this r in terms of b and a. So it will be r equal to absolute z equal to square root of a square plus b square. So this is the modulus of this complex number. So we have to follow this to find the modulus of these two complex numbers. So let's do that. Say I am taking Z1, coordinates 4, 3, So I got the value for the modulus, I mean R, equal to absolute Z1, it is 5. So I put here 5, same as this one. So let's move for the Z2. So coordinates, here I got -4, -5. So I found here absolute Z2, it means also R, I mean modulus, it is square root of 41. So here it shows square root of 41. This is the modulus of this complex number. So this is the way to find modulus. So let's move in the next slide to find the arguments of a complex number. It is same diagram, but there is some additional things I have done here in regard to the arguments. So what I have done here, I put an angle, this theta. It means we have to calculate the angle theta between the positive x-axis and the line joining AB to origin. Very clear. So this value, it is the argument of this complex number, this theta. So I am taking two complex number here. So let's see how to find the argument. This is for Z1. So I have to find the theta. That's our target. So what we will do first, we have to write the formula here. Already I wrote argument Z equal to theta. I mean this theta equal to ARG, argument Z equal to theta. So what is this here? Tan theta, it will be this B divided by A. So same way, because this is 4 means vertically this 4 and 3 means this horizontal, this 3. So we have to get this theta, I mean tan theta equal to 4 by 3. So theta will be tan inverse 4 by 3. Using calculator, we got 53.13 degree. So this is the value for the argument of these complex numbers. Now I am taking the second complex number. Here there are some additional informations we need to learn. Say here I put this angle alpha. I did not put theta, I put alpha. The reason is, first I want to find this angle. In the same procedure, the way I did here, say if it is a right angle triangle and tan alpha, it will be equal to 4 by 3. So alpha will be 53.13 degree, same as this one. But question is, this value of alpha is not the argument of this complex number. Reason is, here I have written the argument must measured from the positive real axis, because our first number, it is from the positive real axis we got this 53.13, but this one we did not get as per this from the positive real axis. That is why I put here another angle to measure this angle. because this is from the positive real axis. So for this one, I mean for this Z2, our argument will be basically 126.87. How it comes? Because we got this alpha equal to 53.13, so we have to subtract this whole 180 degree minus 53.13, so we'll get this. So it satisfies this condition. It must be measured from the positive real axis. That's what it is, 126.17 for these numbers. So let's move in the next slide to see how to find in other form like polar form. So here, position of a complex number, as we know, it is uniquely determined by its modulus and the argument. Already we learned it. But these descriptions, if it comes in our expression like this one, because already we know what is modulus and what is argument. If we give the description as this one, then this form, it is called polar form, because this is argument. I mean, this is the argument, this is the modulus. Now here, already this is the same diagram. So we are trying to get this form, taking the example like this, say Z1, Z2. So it will be very clear to us how to get this. So let's take this Z1 3 plus 4j. Already we have taken in previous slide. Already we calculated 53.13 degree. This is the argument, and for the second one, this is the arguments. To satisfy this, because we need here modulus also. So for these numbers, we have to find the modulus. It will be 5, because we know 3 square plus 4 square, then a square root, it will be 5. So what you got here? We got the modulus for this number, as well we know the argument is 53.13. Surely we can write polar form of a complex number. I mean, these numbers polar form we can write as this. Because look at this r, we put this 5, and this theta we put here 53.13. So we got the polar form of this complex number. Again, for the second one, for this complex number, we are finding the modulus. What is that? 5. We know the formula how to get that. It is 5. So let's see the argument. So already we know it. What is the argument for this number? Because we know 53.13, but we have to measure from here. So it will be 126.87 degree. Now we know the modulus, we know the argument. So surely in this form, we can write z equal to 5 and angle will be 126.87 degree. So it is the polar form of this complex number. So we are very clear about this now. Let's move in the next slide to see other form of writing the complex numbers. Other form is this one, r cos theta plus j sin theta. So this form, how to get that? We have to use the right angle triangle to get our polar form complex number in this form. So how to get that? So let's take this right angle triangle. So surely we can find cos theta. It is from trigonometry. Cos theta equal to a by r, because this is a, this is b. So a by r, it is cos theta. Sin theta will be b by r. Rearranging, we can write a equal to r cos theta, b equal to r sin theta. So surely putting these two, real part and imaginary part, in this complex number form, we can get z equal to r cos theta plus j sin theta. Look at this form. So we got this form. Now let's see an example. The complex number, say z equal to, we have, as I told, we have to use this z equal to r, angle is theta. So our modulus is 4, argument is pi by 3. So we have to find the real and imaginary parts and express in this form. So let's first use this. So this is the complex number we are sketching here. Angle is pi by 3. It means this is the argument. And we have this modulus 4. So we have all the informations. Only the thing, we have to use this equation. So what is that? A equal to r cos theta. R means 4. Cos means pi by 3 cos. So it will be 2. Again, b equal to r sin theta. So b sin pi by 3, 3.46. So what we got? So easily we can say this one we got. It means we can say there is an alternative way of expressing complex number with modulus r, argument theta. So we understood now. And our complex number already we got in this form, but we use these equations. Sin, I mean trigonometry, cos theta, sin theta, then we got this, then we use this. So in the next slide, we'll show you how to get this polar form multiplication and division. Very important things. So what we are doing here? It is simple multiply and divide. So if we multiply, it takes this form. So seeing this equation, we can say multiply their moduli and add their arguments. Look at R1, R2 is the moduli. Multiply these two and add these two arguments. That is the multiplication. If we do division, it is what? Divide their moduli R1 divided by R2 and subtract their arguments. So we are taking one example to apply these two equations. So here I am taking Z1 equal to this, Z2 equal to this. This is polar form. So how to multiply? Very easy. We have to follow this. These two modulus will be multiplied, but argument will be added. So we got 15 and 55 degree. If we do division, it's very easy. Dividing of the modulus and subtract their arguments. So we got 5 by 3 angle minus 15. And that's all for today. Thanks for watching.